Alright, let's look at an example of this idea of a match column. So again, the idea here is to be able to take a set of inputs and tell if we match a particular pattern. Basically, it's a decoding kind of thing. And in this case, I used the graphical layout editor to design this circuit, and I have a series of blocks basically that say, do I want this particular bit of my number to be a 0 or a 1. So this first column, for example, matches a 0, 0, 0. The second column matches a 1, 0, 0. The third a 0, 1, 0, all the way up to column 8, which matches a 1, 1, 1. And the behavior of these cells is as described in the lecture part of this discussion. Basically, each of these blocks that match a 0 will take an input from the west, and if it's a 0 and the input from the north is also a 1, then it will pass a 1 to the south. So the basic idea again is each of these takes an input from the north. If the input from the north is 0, we know we don't match. If it's a 1, we see if the incoming bit matches either a 0 or a 1, and if it does, we pass a 1 to the south. So the signal traveling through the south means we've matched everything above this cell up to this point. If the cell on the very bottom outputs a 1 to the south, it means we matched all the cells. And matching is simply a question of taking the value coming in from the west, and if it's a 1 and we're trying to match a 1, pass a 1 to the south if we also have a 1 from the north. If we're expecting a 1 and we get a 0, don't match. If we're expecting a 0 and we get a 1, don't match. So very straightforward description, but we put these together and we get these match columns that we can use to examine the value of an input coming in on the left in this case and cause one of these outputs to fire. So we can simulate this by using the Java simulator, and I'm going to load the binary grid that corresponds to that layout into here. So here's my 8 columns. Here's my input on the west, and my least significant bit is here, so I'm inputting 0, 0, 0. And you can see this first column is putting an output to the south that's saying that I've matched the number 0, 0, 0. If I change my number to a 1, I'm now matching this column, so this becomes my output. If I put my input to 2, I match in this third column. If I put it to a 3, I match the fourth column, and you get the idea. I can count through all the possible sequences. There's 4, there's 5, here is 6, and if I put my input of all 1s, then this final column, column 8, puts an output to the south. So you can use this basically as decoding logic. I can stimulate one of 8 rows of cells based on the binary value coming in here. When we talk about things like sequence generation, this is one of the earliest techniques that were used. By sending a counter into a series of match columns, we could drive an output through a series of parallel columns, and that signal would be used to read cell configurations down each of these columns and then transfer them into some part of the cell to start configuring circuits on the fly. We'll get to that in a later lecture.